Keene,
Here.
Thomas Cruz,
Here.
thank you. Also, please note that we have several RTC staff on the line for today's meeting. This includes Mr. John Pinuelos, Senior Director of Engineering, Ms. Teresa Gazer, Director of FAST, Ms. Gina Kendall, Principal Project Engineer, Ms. Julia Urovich, Senior Project Engineer, Ms. Maria Brace, Transit Operations Supervisor, Ben Collado, Assistant Transit Operations Supervisor, and Ms. Salma Flores, Office Specialist. As the chair mentioned, I have a few housekeeping items to go over. When the chair asks for comments from the subcommittee or calls for a vote, please remember to unmute yourself before speaking. Remember to state your name for the record before providing comment. Be sure to mute your line if you are not speaking. Voting will be done verbally. The chair will call for ayes and nays. If there are no nays, then the motion will carry. If there are nays, then a roll call vote will be required. In the event of a roll call vote, please wait for your name to be read to provide your vote. The chair will call for any comments or questions after an item has been presented. Thank you, Chair Cruz.
Thank you. And now I'll turn it over to Ms. Kendall for the first item.
Thank you, Chair Cruz and members of the subcommittee. I'm Gina Kendall, Principal Project Engineer for the record. The first item on the agenda is to conduct your first citizens participation period. As you know, on March 22nd, 2020, the State of Nevada Executive Department issued Declaration of Emergency Directive 006, which suspended the requirement to have a physical location for public meetings. Pursuant to Directive 006, and for the health and safety of the community, this meeting is being held telephonically. To allow for public participation, the RTC is accepting public comments via email at publiccomments@rtcnv.com. Comments can be submitted to be read aloud or be added directly to the written record. Mrs. Reagan Lively will read the public comments received by the RTC.
Thank you, Chair Cruz, for the record. So the first time set aside for public comment. This time is limited to comments on items included on the agenda. Comments will be limited to the first 500 words, with the remaining words to be included in the written record. Do we have any comments?
Thank you, Chair Cruz. Reagan Lively for the record. Before I continue, I do just want to make note that Michelle Castro has joined our call as well. At this time, there are no public comments. Chair Cruz, that concludes the public comments received.
Thank you, Reagan. Moving on to Ms. Kendall for item number 2.
Thank you. Item 2 is to approve the minutes. The minutes are in order and ready for approval.
Are there any comments or questions from the subcommittee? If there are no questions or comments, do we have a motion to approve?
This is Jim Keene with Boulder City. I'll move to approve.
All those in favor say aye.
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 Aye. Aye.
All those opposed say nay. The motion carries. Thank you. Moving on to the next item.
Thank you. Item 3 is to receive a report from Ian Machin with Ludian LLC on the findings of the Eastern Adaptive Traffic Signal System project. Go ahead, Ian.
Thank you, Gina. My name is Ian Machin. I'm the CEO and founder of Ludian, an intelligent mobility consult based in Henderson in Nevada. So I'd like to talk to you about the pilot study that I've been engaged in assessing on Eastern Avenue Corridor to assess the use of adaptive signal control technology. Next slide, please. The project on Eastern Avenue included 14 intersections starting at Beckler Drive all the way through Eastern and finishing at Pebble Road. Each intersection was connected onto the Rhythm in-sync adaptive traffic signal system, and we conducted a number of tests and information gathers along the corridor to analyze the use of the adaptive system. The project was split between City of Henderson and Clark County for jurisdiction under the intersections, and then managed by the RTC. Next slide, please. The system was switched on and commissioned on the 19th of October 2020 on the 14 intersections, where we then collected data and analyzed. Next slide, please. So the role for Ludian on this project was to understand how the adaptive signal technology changed the operation of Eastern Avenue, and this was done in a number of ways. So pre and post study data was captured, and this was captured using a number of systems. So there was Bluetooth technology that was deployed along St. Rose and Eastern Avenue, again to capture the change in traffic flow, traffic volumes, and traffic speed. Also the use of a platform called Streetlight Data to analyze the individual intersection delays for each turning count movement, again to understand how the adaptive signal had been changing the way that the traffic flow was on Eastern, and also using the fast AVL data. So this was what we call probe data from vehicle journeys up and down northbound and southbound on Eastern Avenue. Again, before we commissioned the system, to look at the before data, and then after the system had been commissioned and fine-tuned, the exact same data was captured to do a comparison of journey time, the travel speed, the amount of times vehicles stopped, and how long they were stopped for. Next slide, please. So in analyzing this data, and the results you see here are from June of last year up until the 28th of February this year, to give us a wide spectrum of data analytics to understand how the system has performed. So we see here northbound and southbound, daily, weekly, and yearly changes. The figures you see in minus means that's been an improvement on the after results. So for example, we had a daily travel time improvement of 1,018 hours for all movements northbound on Eastern Avenue, and for southbound, a total improvement of 311 hours per day for all movements. And for stop duration, again, a total, as we have there, of 809 hours saved on the number of hours a vehicle was stopped on Eastern. And taking that all the way to the column on the right, we can roll this up into yearly savings. So for all movements traveling northbound and southbound, the time saved for the users or the drivers of Eastern Avenue was 483,718 hours, and the total time saving for vehicles stopped was 294,323 hours in savings. Next slide, please. And to roll this up on a percentage change, and again, this was looking at before data and after data, so the same analysis taken prior to the system being switched on. So for northbound, there was a 31.1% improvement in speed on northbound, and an 8.2% improvement in speed southbound. The travel time on northbound was reduced by 24%, and on southbound reduced by 8.6%. the times that vehicles stopped along the Eastern Corridor, again, this is looking at that whole 14 intersection route of about 3.1 miles. We had almost 70% reduction in the number of stops northbound and 37% southbound. And the amount of delay this led to for northbound was a reduction of 57.5% and southbound 10.6%. So overall improvements in measurements along the Eastern Avenue corridor. Next slide, please. Another important measure as part of the analysis work that me and the team did was the changes in CO2 emissions. So based on the improvement in cruise speed along Eastern Avenue, we can calculate the tonnage. So for northbound direction here, we had a reduction of 3.2 tons of CO2 emissions. Again, based on an average daily vehicles of 31,000, just over 31,000 vehicles. So this is for northbound. So again, a big reduction in carbon emissions. And next slide, please. And for southbound, we had a total reduction, and this is per day, of 0.96 tons. And again, the same was for northbound. This is the daily savings in CO2 emissions on Eastern Corridor. Next slide, please. So as a roll-up for the travelers along, or the drivers along Eastern Avenue, again, 3.2 tons for northbound, almost 1 ton for southbound, and calculating the time saving based on the trip data, the average user of Eastern Avenue, assuming they do 1 trip in each direction per day, so it's a round trip, the savings per vehicle driver is $342.67 per year. That's savings in the pocket in time saved and fuel costs. Next slide, please. So to summary of the benefits that we've seen by the implementation of the adaptive system along Eastern Avenue is an improvement in the duration of travel, reduction in the traffic congestion, a big improvement in the air quality, which has a reduction in queuing vehicles, which leads to improvement in quality of life because we're spending less time on the corridor and less time in queues. And again, lastly, reduction in the number of stops at intersections. So it's a more progressive flow along the corridor. Next slide, please. That concludes my presentation. Thank you very much.
Are there any questions or comments from the subcommittee? If there are no questions or comments, we can now move on to the next item.
Oh, sorry, I was on mute. Thank you, Chair Cruz. Item 4 is to receive a presentation from Reggie Chandra with Rhythm Engineering on the technologies to improve traffic signal performances. Go ahead, Reggie.
Thank you very much. Hopefully my audio is on and you can hear me well. What you just saw was the results of deploying one of Rhythm Engineering's solutions, adaptive traffic signal system called InSync. So I was asked to share with you a new solution that we have presented for optimizing traffic signals. So our company, Rhythm Engineering, essentially we are specialists in optimizing traffic signal operations. So here, in this particular presentation, I'm going to share with you some of the challenges traffic engineers face in timing traffic signals, and then perhaps a new blueprint to attack traffic signal timing. Next slide, please. So there were several studies that came out. One from NTOC, there were actually two studies, National Traffic Signal Operations Coalition. So they came out with a traffic signal report card and gave, in 2011, and gave a grade of D+. For traffic optimization in the United States. So essentially, my research and analyzing other reports, about 70 to 90% of the traffic signals in the United States are not optimized. What I mean by this suboptimal functioning is that it's not that whether you deployed a timing plan, 12 months before or 36 months before. It's whether that signal is operating at its most optimal capability. Next slide, please. So in order to do that, we have to take a look at the timing workflow and try to understand why about 70 to 90% of the signals are operating at a suboptimal level. So looking at the workflow, the first thing that we do as practitioners that want to optimize traffic signals is send people out to the field to collect data. There are other ways of collecting turning movement counts, but the most prevalent way is actual human counts, where we send someone out Tuesday, Wednesday, Thursday, knowing fully well that the other days are anomalies. In other words, Monday's traffic is very different from weekend traffic, Saturday or Sunday. Even those 2 days, the traffic patterns are different. But we cannot afford to collect data all 7 days. So what we do is we send people out Tuesday, Wednesday, and Thursday, saying those are typical days to collect data, and then we collect the data and we create our timing plans. So this is the first step in our current traffic signal timing workflow. Next slide, please. The second step is that we take this data that we have collected over these 3 typical days, Tuesday, Wednesday, Thursday, and then we input the data into traffic signal timing plan creation software such as Synchro, which is the most popular one. For the old timers, you had options of Passer or Transit, TPAC, et cetera, and then you generated a timing plan on paper. So for the real old timers, you actually used your drawing board with a T-square and et cetera, and created your bandwidth diagram and started moving the bands up and down to create the best offset. So, but this is the second step. First step is data collection. Second step is creating a timing plan. Next slide, please. And then what we did was we took the timing plans and then we converted them to a format that traffic signal controllers could understand. So you had the output, then you took the plan, converted it so that you can input into a central system software. Next slide, please. Which is basically this particular software, the central system software, is what you use to download the plan to the controller. And the final step, next slide please, is that the traffic professional went down to the field and started driving up and down and tweaking the offsets and the splits to make sure everything worked well in the field. In fact, if we use any of these models, we have to spend a lot of time in the field to tweak these timing plans because the models themselves are inaccurate. The models do not recreate reality. So this is the current workflow. That concerning the models, that's a discussion for another day. Most of them use a modified form of the Webster equation with the faulty assumption that traffic arrives at a uniform rate, which is not true. Traffic arrival and departure have a stochastic nature. It's never deterministic. So, in other words, the takeaway is that the models themselves are not accurate, so engineers and technicians have to spend a lot of time out in the field tweaking the created timing plans. Next slide, please. So we can say the current timing, the workflow, which is collecting data, creating timing plans using one software, converting that to another format that a central system can take in, and then download to the controller, and then drive the corridor to tweak the timing plans. Yeah, this workflow is broken. It takes anywhere from 2 months, 3 months, or even 6 months to create a timing plan, collecting data, using contracts, consultants, et cetera, et cetera. So I want to, next slide, please. I want to introduce to you perhaps a better way because we have insufficient data. The workflow is complex, and most agencies don't have the resources to create timing plans when they need them to be updated. So next slide, please. So in the new blueprint I'm going to be introducing, so imagine what it would be like if, next slide, that you had turning movement count data for every day of the week, not just a snapshot where you sent people out and collected data one day in a week, and perhaps you collected data, you had an aggressive count program by which you could have data once a year. Most agencies don't have the luxury of having ongoing traffic signal count programs. So imagine in a new blueprint, new methodology, you had data available for every day of the week, and the data collection happened 24/7, 365. Next slide, please. So also imagine that you had fine-tuned models. Let's assume models such as InSync Lite, okay, a proven model that works in the field. Imagine if you could create a timing plan in 5 minutes using the automatically collected data. Next slide, please. And you could, with the data that you had 7 days, you could collect data 7 days a week and create timing plans for your signals for each day of the week that you not have to compromise, forcing the signal to run the data collector on Tuesday, Wednesday, Thursday, and force the signal to run other 4 days of the week using that data. Next slide, please. And so in this particular workflow, the 3-month or 2-month to 6-month workflow is compressed to under 5 minutes. The professional is able to automatically collect data, and I will show you how we collect the data, is able to use the built-in software to create, optimize signal timing plans, and then with the push of a button, download it to the field and operate your traffic signal. So it's end-to-end, from collection to traffic signal operation. You're able to do seamlessly, and for a regular person, it takes about 5 minutes to create timing plans. Okay, next slide, please. Essentially, I mentioned 3 steps: collection, creation, and control. So we'll look at each one of those aspects very quickly. Next slide, please. So the data collection, next slide, please, is the step 1. Step 2 is the timing plan creation. It's all seamless. There is a AI processor in the field that is collecting the data 24/7, 365, and then the timing plan is created using a software. You can create it using your laptop or your desktop. Next slide, please. And the software is so intuitive. This is what is needed to create timing plans for an entire arterial or city network. You can create, store, and then you can download it by time of day. Next slide, please. And step 3 is basically download to the field from the software itself. So under 5 minutes, you're able to collect, create, and control your intersection. Next slide, please. So, and this solution is what we call Code Green. You can also call it, if you want, InSync Lite. Very similar optimization models as you see in Eastern. It's the single operation is digital. While we use cycles for Code Green, there are no transition between cycles because it's all digital. Architecture is a digital state machine. The technical term is finite state machine. So there is no transition between plans. You can have any number of timing plans running through the day where essentially you can create timing plans based on the data that is collected. Next slide, please. So essentially the hardware is very minor number. We are compatible with all manner of controllers and cabinets. Can be NEMA, TS1, TS2, 332. It doesn't matter. We are technology and vendor agnostic, and then we seamlessly integrate with the hardware out there. Like in Eastern Avenue, we have Siemens controllers as well as Trafficware controllers. We are basically agnostics. We are compatible with the central system and also the controller. So there is one large field of view camera, one or two. The intersection is large. There are two cameras to increase the accuracy. The field of view is about 130 degrees. And from the processor, it's actually a GPU, a graphical processor unit running artificial intelligence. Next slide, please. So the data collection is powered by artificial intelligence. We use what is called as a convolution neural network to actually recognize, not detect, recognize objects in the field of view. And as I said, it's real-time data collection, and it's 24/7, 365 data collection. Data gets stored. Next slide, please. Yes. Next slide. So the technology I mentioned, I know the slide got lost in translation here. The camera uses the same technology that's used in autonomous vehicles, convolution neural net. It uses it for detection and classification. We have a solution where we can detect, track, count pedestrians and adjust the signal operations. In other words, if we find that there is a pedestrian that is not cleared on the crosswalk, we can extend the ped phase, or we can just put a hold on the controller so that the pedestrian is able to clear the cross street. And again, it's based on how you configure it. Next slide, please. So again, it's a very mature technology. So this is actual video you can see on YouTube. A convolution neural net looking at objects. We use a combination of two architecture. If you see the bounding box, that is using a methodology called YOLO. You only look once. And then inside that box, it's just one very fast, one pass. We look at the object and recognize the object. Next slide, please. This is an actual video capture from one of them, our field deployments. We are actually counting cars as they turn inside the intersection. It's not stop bar detection. It's actual turning movement counting. So we know when a car is leaving a stop bar and whether it's turning left or going through. So we are counting the actual turning movement count of the intersection. Next slide, please. So the timing plan, the steps are these. We collect data. You probably need to click through, Reagan. So we use the data collection, 24/7 turning moment count. We use the built-in software to create the timing plan. We fine-tune that by adjusting the bandwidth and then download to the controller, and voila, we have new optimized timing plans running in your controller. Next slide, please. So the benefits, if you don't mind, just click through. You don't have to send people out to count cars anymore. You have a AI person sitting, or you have a person sitting there 24/7, 365, counting and submitting the data for you to analyze. And the timing plan creation is pretty efficient and simple. You can create timing plans under 5 minutes, and you can essentially have timing plans for each day of the week. Or if you have a ball game, you can create based on the actual data that you collect. You can create a timing plan for special events as well. There is no transition, the signal transition between timing plans, because it's digital in nature. It's one integrated software. It's seamless, basically. And then it's all fully compatible with all existing hardware and software. And your infrastructure does not need to be upgraded in order for you to run this system. It's a plug-in to existing infrastructure nature of architecture. Next slide, please. So I think that with that, I will take any questions that you may have.
This is Eric Hawkins from City of Henderson, for the record. Just a question. I know you mentioned, Reggie, about the grading for overall the country. Did it say anything about Las Vegas Valley, or did it go that detailed?
It's kind of an old study. I know that there is an INRIX report that just came out with data. But this is conducted, I think, 2 studies that were conducted a while back. It's based on self-reported data. I am not sure. I've not gone through that in detail. I just looked at the overall national performance and pulled the grade out of that. But I'll be more than glad to send a copy of that to you. It's a public document, or look and see whether there is any mention of the Vegas region.
Thanks.
Mr. Chairman, this is John Penuelos with the RTC. Do you mind if I ask a question?
Feel free.
Thank you. So just to be clear, Reggie, this is not an adaptive system like you put in on Eastern. This is a tool that collects data, like you said, 24 hours a day, 7 days a week, that then goes into that user interface to design a time of day plan, and then that is downloaded into the controller. So it's running fixed cycles during fixed times a day, but the improvement over how we're doing it now is that it's based on real high resolution data, turning movement counts through the intersection. So there's no adaptive qualities to this. It's just better because you're using data. You have a complete picture of what's going on in the intersection. Is that right?
That is correct. The adaptive system which is InSync and Code Green, I like to use the metaphor of a Ferrari and a Ford, so to speak, or a Toyota Camry, workhorse. So Code Green is going to need human input for new plans that are created. So it's running a typical timing plan with a fixed cycle length, and you can choose the time of day operations as well. And also the price is quite affordable. It's probably 1/3 cheaper than a InSync system. So a lot of engineers like to play with their signals. Okay, I want to analyze the data. So this is a tool for someone with a little bit of time to create and deploy timing plans.
So that user interface, again, John Penuelos, that takes in the data, that's a starting point, I would imagine. And now the engineer, the technician, the practitioner, the expert can then sit down and tweak and say, okay, that's what the data says, but I know that in this particular instance, maybe there are other factors that might be political factors or other things that professionals have to take into account, and then they can tweak that kind of basic plan that the system gives them as a starting point, and then there are capabilities to change it as the practitioner sees fit. Is that accurate?
That is 100% accurate, yes.
Okay.
Yeah. This is a timing plan, a traffic signal timing plan, sort of seamless integration of the workflow, so it allows you to create timing plans very quickly.
Got it. But you're not locked into them. It's a starting point.
It is a starting point. That is correct.
Got it. Now, you also mentioned that, you can have as many plans as you want. I think typically in Las Vegas, Teresa could chime in and correct me if I'm wrong, but a typical intersection in the Valley might have 6 or 7 different plans during a day. Maybe that's a little bit of an exaggeration, but an AM, a midday, a PM, and an overnight, maybe a transition plan between, early in the morning and that first AM peak, there might be a transition plan in there. You said, and of course there's a practical limit to that in practice, because each one of those typically come with a cycle change, and then there's inefficiencies built into changing from 120 to the 160 to the 180 second cycle as traffic builds during the day in a traditional system. You said something about transitions. You can have as many timing plans as you want during the day based on the data, and there's no transitioning between those timing plans, which would be a benefit, I think. Could you go into a little more detail on that?
Yes. A transition, as we see it, is that traditional controllers skip phases, do unpredicted things when it changes from one plan to another. So with us, it's a state machine. There is no transition. There is no analog way of getting back to multiple of the midnight clock if the cycle length changes. When the cycle length changes, there will be a break in the coordination because signals have to, the car would have started from the first signal, and when it gets to the third signal, the plans have changed. But there is no, it's all done digitally, just as you would see InSync do it. It's the same architecture.
So it can pick the most appropriate phase pair that is called for, but I can understand it in the InSync system because it's seeing the traffic and it's deciding for itself which phase pair can go. I don't understand how it does that if it's running a fixed timing plan.
It does see traffic. We read the detection data, so we know the demand of whether there is a car there or not, and also but it's limited to running the cycle. So the multiple of the cycle for the signal to achieve that from the midnight clock is what causes transition. So that doesn't happen. You don't have to be a multiple. You're looking at the digital time and saying, okay, that's where the offset need to be.
Okay, I get it. Thank you. Thank you, Mr. Chairman. I'm done.
Are there any further questions or comments from the subcommittee? There are no more questions or comments, so please move on to the next item.
Thank you. Item number 5. Item number 5 is to approve revision to the Uniform Standard Drawing 313 for streetlight standard general notes, 314 for streetlight standard with 2-inch pipe arm, and drawing 315 streetlight standard with double 2-inch pipe arm, and Uniform Standard Specification Section 623L.02.01 streetlight poles and arms. Mr. Chair, we've had many discussions at previous meetings on this issue, and at the last specification subcommittee meeting, this item wasn't voted on, and the committee decided that any and all new comments or concerns will be discussed in depth at the spec and drawing working group that we recently established. Therefore, Mr. Chair, if it's okay with you and the committee members, I recommend that after discussion today that no motion or action be taken at this time.
Oh, okay. Are there any comments on that from the subcommittee?
Mr. Chair, this is Jim Keene with Boulder City. I'm also on the specification subcommittee, and I agree with the recommendation that was made to send it to the new working group. It's exactly what they're being formed for.
Oh, okay. I would also agree with that. Do we have any other comments or concerns with forwarding it to the working group? Do we need to have a motion here to move it to the working group?
I don't think so. I don't think we do.
Okay. And if there are no more questions or comments, let's move on to item 6.
All right, thank you. Item 6 is to discuss the work zone and temporary traffic control related items. In your backup, you've been provided a C and orange report for your review.
Are there any comments or questions from the subcommittee? There are no comments or questions on temporary traffic control related items. Let's move on to the next item.
Oh, great, thank you. Item number 7 is to discuss and resolve various transit system or traffic engineering operation and law enforcement issues. Mr. Chair, today I've invited Maria Brace with Transit to speak today on some recent transit issues that she's seen. Thank you, Maria. You can go ahead.
Thank you, Gina. My name's Maria Brace. I am RTC Transit Operations Supervisor, just for the record. So we have several reminders to begin with. I think that open communication is very imperative for us to have open communication with the traffic control plans, the barricade companies, and as well as the construction companies. We have over 800 drivers, so we need to plan for those. Any bus stop closures, we have to make sure that the information gets out to the drivers as well to the passengers. Sometimes we do receive last minute notices or requests for us to close a bus stop or so. So it kind of puts us in a bind to trying to figure out the plan or the best plan for that. We do request, and this is a reminder, I'm sure this is in the documented in the documents that they do provide. A minimum of 72 hours would be very helpful, or is very helpful for us. Closing no more than 2 consecutive bus stops, very helpful. Anything more than that extends the distance, for people to try to access a bus stop, especially people with wheelchairs or walkers that would have to, figure out a way to get to the next available bus stop when this occurs. And some of the things that we have experienced recently with traffic control plan setups is that that we may not necessarily, it may not necessarily affect a bus stop, but it does, affect the movement of the bus or the path that the bus is traveling on. So it makes it sometimes the traffic control plans are set up to where um, the the space or the room that is, allowed for traffic to make a right or a left. Sometimes the room is narrow or very limited space for the buses to conduct or maneuver around the traffic control plans. So what we find in these situations that even though a bus stop is not affected, the buses can't really make their turns, so we have to detour um, the buses, and so it adds to the bus stop closures because now we have to detour the bus. So sometimes traffic control plans, again, they're if they're set up to a certain way, um, sometimes buses are not, the first thing that they think of, and that's obviously, I'm sure that that's normal, but a reminder or something of that sort would be great for traffic control traffic control companies and construction companies. Um, Another issue that we have experienced most recently with two different projects is the starting of another phase when the previous phase is still in the works or has not cleared the cones and the cone setup is still up. We have experienced that, and it extends. So it extends the area of the work area for construction, but it also extends the um, the bus stop closure for us as well. So if the work is in phases, it would be nice if they can finish one phase before they start on the following phase of that construction project. But not that doesn't always work that way. It'd be nice for them to be mindful of that. Um, Another item that we have found some issues is that sometimes, we understand that construction projects are fluid, and depending on what they find or may not find in the area that the work zones that they're, trying to figure out or trying to work on. But sometimes the updates as far as times and dates, when they change, sometimes we do get notifications and other times we don't. So we end up, having to send people out there to kind of find out if the work has been extended or if there's, different things going on. So there's an opportunity there for improvement on the communication. And then one last thing is that, I know that during the pandemic, uh, most of the construction companies were allowed to extend their work zone or whatnot because there was hardly any traffic, any pedestrians as well. But now that things are, starting to reopen and stuff, um, we probably need to think about scaling back the work or even scheduling it overnight just because it's affecting a little bit more, it's affecting more people and it's affecting um, buses and traffic a little bit more. So that's also an item that that can use some attention. And that is all I have for now. Thank you, Gina.
Thank you. Chair Cruz, to you.
Okay, thank you. Are there any questions or comments from the subcommittee?
Mr. Chairman, if there's nothing from the subcommittee, I had a comment, if I may. John Penuelos again for the record.
Okay, feel free, John.
Thank you, Tom. Great information, Maria. Thank you very much for coming in. And you're going to be a recurring guest to be in this meeting. The previous item on to discussing traffic control work zone issues. What we've done is, many of you can remember we used to have what we called the Cone Management Working Group. That was a working group established by our regional project coordination committee. After meeting for a couple years, it was realized that maybe this meeting, the operations subcommittee meeting, was a better place to have those kinds of conversations, since the traffic engineers were here, and typically the barricade inspectors, the people that handle the temporary traffic control, not in every agency, but in most agencies, they answer or in the chain of command of the traffic engineers. But even where they're not in the direct chain of command, they're still, a team. So those types of issues come into this meeting are going to be great to hear. We have the ability to form a working group to address particular issues. Those issues that you brought up, Maria, are just so incredibly important. Having your voice here in the committee is going to be great, so you can constantly remind the committee members and the public, those things that we need to address. Bring that perspective that is sometimes it's always there. It's always appreciated. I know the people that look through those plans and approve those plans, and the people that set up those plans, and everybody's aware of transit, but it really helps every once in a while to to really focus on it. So the vehicle will be in place to address those types of issues and improve those issues, through working groups or through direct communication through the committee. So I just wanted to throw that out there because we had some questions on, hey, what happened to the Cone Management Working Group, and how are we going to handle, the issues that came up where the work zones are affecting bus stops, and like you pointed out, and I really appreciate it, is that you can affect the bus transit or the transit operation dramatically without necessarily affecting an individual bus stop that goes beyond just the bus stops, and that's a wonderful reminder. So thank you for that. So more to come, and we really appreciate you being here. That's all I had, Mr. Chairman.
Thank you so much, John.
Okay, thank you. Are there any other comments or questions from the subcommittee? There are no more questions or comments, then we can move on to the next item.
Thank you. The item number 8 is to discuss topics of interest. This is an opportunity for subcommittee members to share updates or information with other members.
Is there anything that a member of the subcommittee would like to share?
Yes, this is Teresa Gazer, Director of FAST for the record. Thank you, Chairman Cruz. There are 3 items I wanted to discuss with the group today to bring to everybody's attention. Item number 1, FAST is finalizing our contract to update the fiber optic mapping software that we are using. Once this is complete, FAST will be moving forward with an ITS master plan in order to inventory field devices and create a plan to identify gaps in our network, improve redundancy, and develop a holistic plan for the ITS network. The second item I'd like to bring up, FAST is currently upgrading their core and hub equipment. Many of these elements are original to 2004 origination of FAST. These updates may require some changes to configuration of field devices, ITS devices, and other devices, but I will return back to this committee as we progress and provide more details. And then item number 3, For improved communications and transparency, staff will be asking vendors to present items of regional interest at either this operations subcommittee meeting or the FAST OMC meeting. Thank you.
I have a question, Teresa, regarding your fiber mapping. Have you guys selected a software to use for that?
Thank you for the question. At this time, we are working to finalize a contract with Schneider Telvent for the mapping system.
Okay. Thank you.
Thank you.
Is there anything else a member of the subcommittee would like to share? If there are no more comments, we can move on to the next item.
Thank you, Chair Cruz. Item number 9, the last item on this agenda is your final citizens participation period.
Okay, this is the second time set aside for public comment. Just a reminder that comments will be limited to the first 500 words, with the remaining words to be included in the written record. Do we have any comments?
Thank you, Chair Cruz. Reagan Lively, again for the record. There are no public comments at this time.
Thank you. Then if there are no additional comments, I'll close this item. If there is nothing else, then this meeting is adjourned.